Welcome to the Lesson 10.5 video. This right here is the parent square root function. That means it's the most basic or simplest of the square root functions, and all other square root functions are just a transformation of this function right here. So let's explore a little bit what this is going to look like if we were to graph it. In order to graph this, we're going to need a table of values. We're going to need some input values or a domain. Those are our x values. We'll take a look at where x is. It's underneath the radical. So you need to think about what you know about the square root of numbers. You can't take the square root of a negative number. So that means that this x right here has to be a number that's 0 or bigger. So my first domain value, my first number I could plug in for x, it could be 0. And if I plug in 0 for x, the square root of 0 is just 0. Then I want to think about what other number could I plug in for x that's bigger than 0, another positive number. Could I plug in 1 and take the square root of 1? Yes. If I plug in 1 for x, the square root of 1 is 1. Now it wouldn't be wise to plug in 2 for a domain value because taking the square root of 2 is going to give you an irrational number, which is hard to graph. So think about what's the next best number to plug in for x, where if you took the square root of it, it would give you a nice whole number. Yeah, you're right. You probably would want to plug in the number 4. The square root of 4 is 2. The next nice number to plug in for x for your domain would be 9. If I plug in 9, I would get 3 as my output. Now if I go to graph these coordinates, I end up with a graph that looks just like this. And this is what a square root function looks like on a coordinate plane. Today we're going to be looking at 3 examples that look exactly like this. We have a radical equation and we're going to be graphing it. But in order to graph it, we need to come up with a table of values. So we need to be thinking about what values for x can we plug into the function that will work. These values for x are called the domain. So we need to be thinking about what numbers can we use for our domain in order to graph. So these are the 3 functions that we will be graphing. Let's take a look at the first one. We're going to figure out what the domain is. What x values would make sense to plug into this function in order to create a table of values? Well, we know that we cannot take the square root of any negative number. So this entire quantity under the radical has to be 0 or bigger. So in order to figure this out, I have to take everything that's underneath the radical and say that entire quantity has to be greater than or equal to 0. Now remember, the domain is the x values. So I'm going to solve this inequality for x to figure out what x values I can use in my table. It looks like I can use any x value that is greater than or equal to -1/2 in my table. So I'm going to write my domain as all numbers greater than or equal to -1/2. Those are the numbers that I can use for inputs into this function. Let's try the second one. Let's find the domain. So I'm going to locate the radical and look at what's under the radical. This number that's under the radical has to be 0 or greater. So I'm going to pull it out and I'm going to set it greater than or equal to 0. Now remember, I'm trying to solve for x since x is my domain. But notice I don't have to solve for x here because it just says x all by itself. So this is telling me that my domain for graphing this equation, I can use any x value that's greater than or equal to 0 and it will work. I'll be able to come up with a table of values. Let's try this last one here. On this last one, again, I'm going to locate the radical and I'm going to take everything under the radical and pull it out. Remember that everything under the radical, that quantity has to be 0 or bigger because we can't take the square root of a negative number. So I'm going to take that out and set it greater than or equal to 0. And remember, the x is the domain, so I solve it for x. And it looks like here that if I'm making a table of values, the domain numbers that I would need to use would have to be x values that are greater than or equal to 3 in order for this to work. All right, let's begin graphing. Here's example letter A. So here we have y equals the square root of 2x plus 1. Now we just came up with the domain for this in the last example. When we're coming up with a table of values to create ordered pairs to graph this, we need to come up with domain values to plug in for x. So over here we were coming up with what numbers we could use for the domain. We said any number greater than or equal to -1/2. So that means we could use -1/2 to plug in for x, and this should work. Now think if I plugged -1/2 up here for x. -1/2 times 2 is -1, and if I add 1, I get 0. Can you evaluate the square root of 0? Yes, it's 0. Now I need to think about what number bigger than -1/2 I could plug in here for x that would work out nicely. Well, if you think about it, you could plug in 0. If I plug in 0 for x, 2 times 0 is 0, plus 1 is 1. And if I take the square root of 1, I get 1. Let's try another number. How about 4? If we plug in 4 up here for x, 2 times 4 is 8, and 8 plus 1 is 9. And the square root of 9 is 3. Let's do one more. We could plug in 12. If I plug in 12 for x, 2 times 12 is 24, add one more, that's 25. And the square root of 25 would give you an output of 5. So finding the domain just allows us to figure out the smallest number here that we can start to plug in to our function. And then we can use numbers that are larger than that. But be mindful about the numbers you plug in so that it works out nicely for you. So now let's go over here and graph. My first order pair here, -1/2, 0. Then I have 0, 1. 4, 3. Now this last one's going to be off the graph, so I'll just go over to 12, about where that would be. And then if I were to connect the points, I'm going to get the same shape as the parent function, but it's just shifted a little bit over here to the left. Okay, so this is what that would look like. Okay, here's example B. Now we have to come up with domain values for x. This one's pretty easy because x is the only thing under the radical. Now we did find the domain by using our strategy from before, and we found that any number greater than or equal to 0 would work out nicely. So let's plug in 0. If you plug in 0 for x, the square root of 0 is 0, add 7, and y is 7. We could also plug in 1. If I plug in 1, square root of 1 is 1, add 7, you get 8. We could also plug in 4. If I plug in 4, square root of that is 2. 2 added to 7 is 9. I could also plug in 9. If I plug in 9 here, square root of 9 is 3, add 7, and I get 10 for my output. Now I have some values here, a table of values that I can graph, use to graph the function. Way up here, we got 1, 8, 4, 9, and 9, 10. So again, it's going to have the same shape as that parent function y equals the square root of x. But we notice here that this one kind of looks like it's shifted up on the y-axis there, right? Okay, that's how I would graph this one. Okay, on this last one here, this is our radical equation, our square root equation. And again, to plug in x values for the domain, we want to find the domain. So remember how we pulled out what was under the radical, and we solve for the x values that we can use. So it looks like we can't use anything that's less than 3, because if we try to do that, we're going to end up getting a negative number underneath the radical, and you cannot take the square root of a negative number. So we have to use values for x that are greater than or equal to 3. So the smallest number I could plug in here is 3. So I'm going to have to use 3. So if I plug in 3, right here for x, 3 minus 3 gives you 0. The square root of 0 is 0. Add 1. There's your output. Then I want to think about what other numbers would be easy to plug in here for x and give me a nice square root of something. So the next number maybe that I want to plug in could be 4. If I plug in 4, 4 minus 3 is 1, and I can take the square root of 1. That's just 1. And then I add here, and I get an output of 2. The next easy number would be 7. 7 right here. 7 minus 3 is 4. The square root of 4, 2. Add 1. And then the next easiest number would probably be 12. 12 minus 3, 9. Square root of 9 is 3. And then add 1. We get 4. So here we just have a quick table of values where we're going to be able to graph. So it looks like I've got 3, 1, 4, 2, 7, 3, and 12 I'm off the graph. But this is what it would look like. So we can see that it still looks like the parent function. It's just a little bit different, but it still has the same shape. Okay, so this is how you graph square root functions. Thank you for joining me.